Today we're starting one of the important concepts of calculus called limits. But before we even dig into the word limits, I would just like you to know that what is the basis? What's the before step for limits? Well, if we just take a look closely in our previous classes, we have learned that we are commonly asked what's the y value at a certain point in x. So if I ask you what is the function of 2, or in other words like what is y when my x is at 2, you guys would obviously just rush to your graph and just like draw a rough line from 2 and then boom, match it up with the corresponding y value. For this, the answer is pretty easy, and then you guys will all shout out that it's all 4. Pretty easy, eh? But now comes the concept of limit. So limit is nothing that it's just simply asking that instead of the exact value at the perfect position, which is 2, I ask you what is the y when it approaches 2. If you guys started to notice, I have highlighted these two things because these two words are not the same. One is finding the exact value of a function. The other is when you are near the function or near the coordinate. So if I'm asking you what is the value of y when x approaches 2. So one common question that should pop up in your head is right now that, okay, you asked me approach 2, but from which side? Like technically I can just go from boom like this, from left to right, or from right to left. So which side am I coming from? Well, that's why we have two kinds of limit, left hand and right. So if we start to see from the left, we notice that if I start walking from the left, let me just animate this for you. So if I start walking from the left, I start to see that first I will be moving from 1 to 1.5 to 1.6, and then I'll reach 1.9, and near 1.9 my value would be something like 3.9, right? And if it was 1.99, then it would be like 3.99999. So in other words, my value eventually reaches to 2 if I come from left. So first of all, let me just give you how you write it down. You first say limit, then you say x approaches a certain point, which in this case is 2, and then you write your function, and then I ask you from which side. So you say from left side, so you put a minus sign on the top of this 2 to show that you're going from the left side, that your stick man is drawing from the left side. And now what did we notice? We noticed that as soon as, like, if I just start like a rough graph, it's going to be 1.5, 1.6, 1.7, 1.8, 1.9, and then we just, when we come from 1.9, we start to see something like 3.9, 1.99, 3.99. And in other words, if I just like keep going on and on and on, you'll start to see that I'm getting closer to what number? 4. So in this rough analysis, that's the idea of something's approaching to a something. So like if I'm approaching to 2, we all know that I'm getting closer to 4, which is the next whole number. Make sense? So this is your value. But sir, what would be the scenario if I come from the right? Let's check that. So if I start to come from right, I start to notice that first of all, this x value would be higher than 2, right? So I'm just kind of shrinking myself. So let's just say if I was at, let's just say a random number, I was at 2.01, then I would be definitely at 4.01. And if I was at 2.5, I would be definitely at something called 4.5. In short, I'm always getting near 4. Hence, by the time I reach like, 2.01, which is something like, let's just say this was 2.1, I would be at 4.1, which is quite near 4. Make sense? So that's why we say from the right. And how do we write this? We say limit x approaching 2 from the right. Now to just denote that I'm going from the right, I'm gonna put a plus sign, and then I'll write the function. And what did we guys notice? We noticed that as soon as we're getting closer to 2 from the right side, I mean like 2.1, 2.01, 2.0000001, we start to get closer to 4, like 4.0000001, like we are eventually reaching 4. Make sense? That's how we just like write the idea. So now if you guys notice that if I go from the left, I'm going to 4. If I'm going from the right, I'm going to 4. Then what does that mean? That means that the limit exists. Or in other words, regardless of left and right, I can just say limit x approaches 2, nobody cares about the direction because from left or from right, we are eventually all reaching to 4, right? So that's why we say limit x approaches 2 of a function, eeny, meeny, tiny mistake, is always equal to 4. Hence, we write this general form which says there's a limit and this limit approaches a or some number, which was 2 in our previous example, of a specific function. Function is your graph, and then you say there's a limit. Just like over here, the limit was 4. Now, for this to happen, there's a condition that whatever answer you get from your left and whatever answer you get from the right, they should be equal. They cannot be different. And if they are equal, then they just simply exist. Now, some of you smart fellows would be like, sir, send them, what's the pretty much difference if I just like, if somebody asks me, what is f of 2 or what is limit x approaches 2 in this question, the answer is pretty much the same, right? Well, guess what? Yes, you're so right on this one. But certain examples in maths are something which does not exist on a particular point. For example, just for like, teasing your brain a bit, if I draw a graph something like this, like let's just say this and then this, and let's just say this was 4 and this was 2. Now if I ask you what is f of 2, half of you guys would be like, sir, I don't know. You know why? Because it does not exist. Did somebody see a big hole in there? Yes, because of a hole, we say that f of 2 does not exist. Like, there is no f of 2. Even if you like plot it and search for f of 2, it's gonna say, bro, it does not exist. So we say it does not exist. But how do we solve a question like this? Then we use limits to our help. We say x approaches 2 from the left side, which let's check what happens. So if we go from the left side, we get closer to this point, which is eventually reaching 4. I don't know if you guys could see it as close, but yeah, I hope it's not pixelated. But we start to notice that we are eventually reaching 4. And so is the case that if I go from the right side, I reach somewhere here, like obviously it's going to be something like 4.05, 4.01, but eventually we are getting closer to 4. Like, I think you guys can pretty much see it. Yeah, we are reaching to this point 4, closer to this point 4. So hence, we say that the limit exists, because since left and right are the same, we say that the limit x approaches 2 exists. And trust me, these questions can be made as scary as they want, but if you know the basics, like these parts, then you would be pretty much good. You don't have to focus on a lot of ideas, because you never know what kind of questions is that. Like, if you want me, I can make the things more freakier for you, and you guys might want to hold on to yourself, because yeah, these questions get pretty rough when they want to be. Like, say it could be something like this, and you're wondering, bro, what is going on here? There is no point. So yeah, but these kind of questions, we'll definitely look into it, and we're gonna look into it in the next part. Thank you everyone for being here, and if you loved it, then do leave it a like and share it among your friends. Alright, thank you very much. Bye bye.